Okay, I hear the recording in progress, so share the screen. All right, so we are here now. We're finished with exam 3. You should have gotten an email back over the weekend from me about your exam score. And I also sent out the video on the solutions. If you did not get your exam score back from me, then let me know right away. We are roughly halfway through the course now. So we're done with 1, 2, and 3. We have left 4, 5, and 6. Chapter 4 upcoming is our biggest chapter. As you can see, chapter 5 and chapter 6 are not that long. So chapter 4 is all a review of trig. It does seem pretty long, but remember, I mean, you can take an entire course called trigonometry, where it's the entire semester. We're only, quote unquote, doing, I think it's roughly a month. Let's take a look. So we don't have our next test until Friday, November the 5th. So yeah, it's about a month away. And it seems like a long way, but remember, you can take an entire class called trigonometry where the whole semester is trig. We're just doing 1 month, so to speak. So this is definitely our longest chapter because it's a review of trig. And a warning, I am lecturing on trig, assuming it's review. It's not brand new. It should not be brand new material. So I will not be lecturing as if it's brand new. It's more of a refresher that hopefully it's, okay, I've seen this before. It's not something brand new. So I will not be going at the speed of which it would be brand new. I'm going to be lecturing assuming you've seen everything before. It doesn't mean I'm going super fast, but faster than if you had never seen it before. So again, everything we do in this chapter should not be, oh, I've never seen it before. I've never heard of that. This should completely be review of trigonometry. You may not remember every little last detail about it, but you should know something about everything that we've said. Say, oh yeah, I've heard of that before. I remember something about it, and so forth. Okay. So that's where we are. So see, so quiz Friday, and another quiz on the 22nd, another quiz on the 29th. And finally, we have our exam 4 on November the 5th, it looks like. Okay. All right, so we have actually, according to schedule, we only have to do up to 4.2. I'll try to sneak some more in to keep that in mind that, you know, on paper, I only have to do 4.2, but I'll probably try to sneak in some 4.3. Remember, Wednesday's a flex day. There's no school, not just my class, but any CSM classes, they're all canceled from Wednesday because of flex day. It's a one-day weekend, sometimes I like to call it. Okay. All right, so we'll begin section 4.2. And again, if you did not get back your test score from me, an email back from me, or you didn't get the video, then let me know. But sometime over the weekend, I should have replied to everybody about that last exam. Okay. Remember, my grading scale is 90, 80, 70, 60. So 90% in A, 80% to B, 70% to C, 60% to D. Less than 60 is failing. If you're off a grade by 1, then those are the minuses, which means 89 would be A minus, 79 would be a B minus. We're not allowed to give C minuses, but that's the idea. And then one more percentage point below that are the plus grades. So 88% would be a B plus, 78% would be a C plus, right, and so on. Okay. All right, so 4.2 is a review of angles. The homework is 1 to 39 odd and 43. So let me show that to you right now. So 1 to 39 odd 43, page 200. Okay, and so there's 1 through about 17 or so. And again, this is for the benefit of those of you that don't have the book and aren't planning to get it. Those of you that already have the book, you've got everything already. And some more here. Some more here. Here. And how far do we have to go? 43-ish. So it looks like there's some word problems at the end, I guess. So there's 43. Okay. All right, so what's up with 4.2? Again, you say, how come there's no 4.1? because there's no homework problems. It's just an introduction, and you can see there's no problems involving it. Okay. But some fundamentals for review of trig. So in trigonometry, we start off going to the right. Here's the origin. 0 degrees and 0 radians is heading to the right, and positive is in the counterclockwise direction. So this direction is positive. These are positive angles. Okay. This would be a negative angle, I recall. All right, so 4.2, you're familiar with degree measure. We also have radian measure. Okay, so we can measure in degrees or radians. Okay. And here's the conversion factor. Put this on your cheat sheet if you want to. Okay. So 1 degree is pi over 180 radians, or 1 radian is 180 degrees over pi. It's roughly 57.3 degrees. Okay. So to convert from degrees to radians, you use either pi over 180 or 180 over pi, depending on which way you're going. Put that in your next cheat sheet if you wish. So what's so good about having the radian measure? Okay. It's based on this picture. The radian measure of an angle with vertex at the center of a unit circle is the length of the arc made by the angle. Okay. What does that mean? If this angle is theta, the arc length is also theta in radian measure. Okay. So let's say if you walk along this arc on a unit circle, this is 2 units, the angle is 2 radians. If I walk along here and it's 0.37, the angle is 0.37. So that's very convenient to have the angle measure match the distance that I walk. Okay. Now in a unit circle, if I go all the way around a circle, that's 2 pi, because this formula for the circumference of a circle is 2 pi r. So if the radius is 1, 2 pi times 1 is 2 pi, right? So that means if I walk all the way around a unit circle, that's 2 pi units, it's also 2 pi radians. So if I go all the way around a circle, that's 360 degrees, that's 2 pi radians. So 360 degrees is 2 pi radians. Okay. All right, and I'll show you some of this in my work a little bit later also. Okay. So I don't think we need any of this yet. Right triangle trigonometry on page 197. Okay, so you should already be familiar with that. A squared plus b squared equals c squared, where c is the square root of a squared plus b squared. Okay. Put these on your cheat sheet also. Length of a circular arc. Okay. Here's r, theta, and s. S stands for arc length. Arc length along the circle. Well, if I go all the way around, it's 2 pi r. Right? So circumference is 2 pi r. If you have a fraction of the whole, instead of going all the way around 2 pi, I have an angle theta. Well, the arc length s is arc length, is that fraction amount, theta over 2 pi times 2 pi r. Very conveniently, notice the 2 pi's cancel out. So s is r theta. Okay, so put this on your next cheat sheet. Length of a circular arc. In a circle of radius r, the length s of an arc with angle theta radians is s is r theta. Very nice formula. Arc length s is r times theta, but theta has to be in radians. If they give it to me in degrees, first you have to change it to radians. And we'll do several problems where we have to change degrees to radians and radians to degrees. That's hopefully not too big a deal. And one more formula, area of a circular sector. It's like a piece of pie. Okay, same picture as this. So you make a cut like so. Over here, we were just talking about the arc length. Here, I want the area of this sector. So if I cut a piece of pie, piece of cake, right? What's the area of this piece right here? Well, again, we can just take the fractional amount of the whole. So if I go all the way around the circle, the area is pi r squared for the whole thing. If you have a fractional amount, theta, well, you just take theta divided by 2 pi. The whole thing is 2 theta. The fractional amount is theta. So theta over 2 pi times pi r squared. Notice the pi is very conveniently cancel out. So area is 1/2 r squared theta. So put this on your next cheat sheet. In a circle of radius r, the area of a circular sector like this, it's a piece of pie, formed by an angle of theta radians, is area is 1/2 r squared theta. Keep in mind, theta has to be in radians. So once again, if they give it to me in degrees, then you have to change it to radians before you start. Okay. All right, and those are formulas that we need here. So let me get started with my version of what's going on. And again, ignore any date that you see here. So we're doing trig review. So here's my spiel on the whole thing. So we have a circle here. Aiming directly to the right, that's considered 0 degrees or 0 radians. Notice I superscript with an R for radians, but the convention is that if you don't put anything, it's understood to be radians. Okay. So heading to the right is considered 0. How come? We decided that. The convention is to aim for the right. And then positive is counterclockwise. So going this way is positive, going this way is negative, right? So that's positive, that's negative. And if I go all the way around one revolution, that's 360 degrees or 2 pi radians. Okay, so on a unit circle, you might recall from trig, what is a unit circle? Circle center to the origin, 0, 0, with a radius of 1. Okay, so I go all the way around 360 degrees, and positive is going this way. How come? We said so. By convention, we decided positive is counterclockwise. And that's also 2 pi radians. So 360 degrees is equal to 2 pi radians, which is 1 revolution. And normally for revolution, we'll just put rev. It's a lot shorter than writing the whole thing. You can notice sometimes I superscript with the R. So what's superscript? Writing above, right? Like an exponent. But again, if you don't put the R, just put 2 pi, it's understood to be radians. Okay. And clearly I can divide both of these by 2 to get half a revolution. So half of this is 180 degrees, half of this is pi. So 180 degrees is pi radians. And based on what we just said, you can just write pi. So if I just write pi, it's understood to be radians. Okay, so if I divide both sides by pi, I get 180 degrees over pi radians is 1. If I look at this and divide both sides by 180, I get 1 is equal to pi radians over 180 degrees. Okay. You might want to put this on your cheat sheet also. It's equivalent to what the text has. Okay, but the number 1 is either 180 degrees over pi radians or pi radians over 180 degrees. And then you say, well, how do you know which one to pick? Normally, I wouldn't even bother memorizing it. Okay, you just want the units to cancel. So I want a degrees on top to cancel degrees in the bottom, or I want radians on the top to cancel radians in the bottom. And I'll show you what I mean by that. Okay. All right, so number 1 through 7, convert from degrees to radians. Okay, so how do I change all of these to radians? 30 degrees. Okay, I already showed you the answer, but pretend you don't know the answer. Okay, I'm going to pick one of these. Okay, now let's suppose I pick this one, which happens to be the wrong one, 180 over pi. If I look only at the units, I have degrees divided by radians. I would have a degree squared. I don't even know what's a degree squared. So it has to be this one, okay? Because if I multiply by pi radians over 180 degrees, then I notice the degree on top cancels degrees in the bottom, almost like a variable, right? Degrees cancel degrees, and I'm left with radians. So 30 over 180 pi comes out to be pi over 6 radians. And normally when we say pi over 6 radians, we just write pi over 6. Okay. Likewise, number 7, negative 72 degrees. Don't get thrown off by the negative. It really doesn't affect a whole lot at all. Okay, negative 72 degrees. Change it to radians, right? So I asked myself, am I going to pick this one or this one? Okay. There's a degree here. So if I use this one, there's going to be a degree and another degree on top. I'll end up with a degree squared. I don't want a degree squared. I don't even know what is a degree squared. But that tells me I need pi over 180 because I want the degree on top to cancel a degree on the bottom. So this degree cancels that degree. I'll be left with radians, which is what I want. Okay, 72 pi over 180. If you reduce, you can actually divide out of 36. Okay, if you don't realize that, you can just do the usual canceling like an arithmetic, like maybe take out a 2 and take out a 3 and so on. You'll eventually break it down to negative 2 pi over 5 radians. Okay, so it looks like to change from degrees to radians multiplied by pi over 180. You're allowed to put that on your formula sheet. Okay, so hopefully that's not too bad. And then how do we go the other way, right? 9 through 13, change from radians to degrees. I just reversed the process. Okay, 3 pi over 4. Now, in the text, it just says 3 pi over 4. But the understanding is that it's radians. So again, for purposes of working this problem out, I will superscript with the R. Superscript, writing above. You've probably heard of subscript also. Subscript means writing below. If you write something below. Superscript, writing above. 3 pi over 4. All right, these are radians. So if I use this same conversion factor that I did before, pi over 180, I would have radian and another radian on top. I would have radian squared, and I don't want radian squared. I want 180 over pi. So how do I know? Because I have degrees on top, radians in the bottom, and I will get these radians to cancel out, right? That radian is going to cancel that radian. And furthermore, yes, the pi's cancel out. Normally, it's not 100% foolproof, but normally you want the pi's to cancel out also. Okay. I mean, there are some times where you're going to have a pi squared, but usually for these kind of problems, you look at it and say, oh yeah, there's a pi on the top, there's a pi on the bottom, they're going to cancel out. All right, and 4 goes into 180 45 times, so 3 times 45. Final answer is 135 degrees. Okay, 11 has a negative. You should not be thrown out by the negative at all. You know, the answer is just going to be negative. 11 pi over 6 radians. So again, I have radians that I want to cancel out. So if I pick pi over 180, I would have radian and another radian on top. I will have radian squared, which I don't want. So to cancel out the radian, I need a radian on the bottom, 180 over pi. So negative 11 pi over 6 radians times 180 degrees over pi radians. And yes, indeed, radians cancel out. Pi's cancel out. Very nice. And then I just have my degrees left. Okay, 180 divided by 6 is 30. 30 times negative 11. Negative 330 degrees is my final answer. Okay. All right, then we have some problems involving determine where the angles coincide. Okay, so I have to talk about something called coterminal angles. So coterminal angles mean they land in the same spot. Okay, so if I go all the way around a circle, that's 360 degrees, right? Okay. So if I have, let's say for problem 15, determine whether the angles coincide. 45 degrees, 405 degrees. All right, so we know 45-degree angles like that. How do I get a 405-degree angle? Well, if I go all the way around a circle, that's 360 degrees, right? So imagine this is 360. If I add another 45 degrees, that lands me at the same spot as 45. So the answer is a yes. Basically, these two angles are 360 degrees apart. You can tell if you have 405 minus 45, maybe I'll just write that. 405 minus 45 degrees is 360 degrees. Right, so that tells me if I go 45 degrees, I land here. If I go 405 degrees, well, I would have gone one complete revolution and then another 45 degrees. So it lands me in the same spot. Okay. So these two angles are called coterminal. They're coterminal angles. So the answer is yes, they land me in the same spot.
So is the word coincide some like calculus term, or is this just something that like there's another term for coterminal?
Coincide is another term for coterminal. In fact,
Okay.
coterminal is more exact. Coincide, I'm not sure why the author used coincide. Coterminal would be more exact. But yeah,
So
that's fine.
so on tests and stuff, we can just use coterminal.
You can use coterminal. I prefer to
Thank you.
use coterminal. Yeah. Okay. Maybe I'll even write that in here. Determine where the angles, I'm even going to cross it out, are coterminal. How's that? Okay, that's all. Okay, how about pi over 6 and 13 pi over 6? So to do this, we're probably not as familiar with radians, but let me subtract. What's 13 pi over 6 minus pi over 6? These are the two angles that they gave me, right? No, it's 12 pi over 6, which is 2 pi. Aha, 2 pi is one revolution. That's the same as 360 degrees. So yes, these two angles are coterminal. So pi over 6, if you might recall from trig, this is 30 degrees. You can memorize that, or you can put it on your cheat sheet, or you can do the conversion factor, right? You might recall pi over 6, this is radians, right? And then I can go 180 degrees divided by pi radians. Cancel, 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 cancel. Pi's are gone, radians are gone. I'm left with 30 degrees. Okay, so you should be comfortable with a 30-degree angle, but you do want to start getting comfortable with the trig terminology that this is pi over 6. So 13 pi over 6 is 2 pi, one revolution, and then another pi over 6. So 13 pi over 6 is going all the way around, and then I land in the same spot. So yes, they are coterminal. These two angles are indeed coterminal. All right, and 19, 150 degrees, negative 240 degrees. So the strategy is, are they 360 degrees apart or a multiple of 360? Like maybe 360 plus 360, which is 720, and so on. Okay, so just subtract the two. So 150 degrees minus a negative 240, 150 plus 240 is 390. So no, they're not coterminal. They're 390 degrees apart. So if they were 360 degrees apart, well, just like this one, right? Then they would be coterminal. But they're 390 degrees apart. So for one of the angles, you go all the way around to get to 360, but it looks like you have to add on another 30 degrees. So they would not land in the same spot. They're not 360 degrees apart from each other. So that one's a no. That's all. Okay. All right, so I'm not going to go much longer for this. I was going to do 23, and then I'm going to stop. Okay, at which point we can ask questions or we can just end early. All right, show the approximate location on a unit circle for the given values of t. All right, so these are all in radians. We kind of have to get used to radian measure, right? I think you're kind of comfortable with degrees, like 90 degrees, 180 degrees, 270 degrees, 360 degrees. What about these guys, right? So 21 and 23 are very similar. I'll do 23, you do 21, and then that's all I was going to do for today. So let's see, negative pi over 4, negative. So yeah, they give me all these negative angles. So negative angles go clockwise. I have to start down. So these are harder than 21. So 21, they're all positive, so you're going this way, right? But for 23, and I'm intentionally aiming toward the right because that's where we start, right? We're going that way. Okay. So negative pi over 4. From trig, I know that's 45 degrees, but in a negative fashion. So positive pi over 4 is 45 degrees that way. But negative pi over 4 is going this way. So here's negative pi over 4, negative 45 degrees. This would be negative 90 degrees and so on. Okay, B, negative 4 pi over 3. Now, if you're comfortable with the trig, you can get it. Okay, so how did you get this so fast? Well, because frankly, it's my job. You know, I live and breathe this stuff, so I'm supposed to know it. But you say, you know, what do I do if I'm not familiar with this? You can always go back and do this, negative 4 pi over 3, and then multiply by, let's see, is it pi over 180 or 180 over pi? I want the pi's to cancel out, so 180 over pi, cancel, cancel. 3 goes into 180 60 times. So negative 240 degrees. And it's in a negative sense. So if I go this away, that's positive 90, right? Positive 180. The negative goes the other way. So I start down. Here's negative 90, negative 180. This would be negative 270. So if I go here, if I'm aiming here, that's negative 180. So I go another 60 degrees in a negative sense. So here's my approximate location. All right, C was much tougher. It's negative 37 pi over 6. Negative 37 pi over 6. So how could I do that? Well, it's an uncomfortable angle. So I want to lop off, I want to take off multiples of 2 pi, so to speak. So here's a strategy. So this is, sorry if you can't read that, it's negative 37 pi over 6. That's a 37. I'm going to add 36 pi over 6. So where'd you get that from? Because I notice this is the same as 6 pi. 6 pi is 3 revolutions, right? So if I go backwards once, twice, thrice, 3 times, that's negative 36 pi over 6. And then I have another negative pi over 6. So this angle is coterminal with negative pi over 6. That's negative 30 degrees. Okay, so one more time, say I don't recognize that number. So I got to get it to a comfortable range. So I added 36 pi over 6 because I realized that is 3 revolutions, 6 pi. So it's backwards once, twice, 3 times, and then another negative 30 degrees. Okay. So here we go. I know it gets you kind of dizzy maybe, but I go around in a negative sense once, twice, 3 times, and then another 30 degrees after that. So here's the angle negative 37 pi over 6, right? So again, and you are supposed to do this on a test or quiz or homework or whatever. So it's not just this angle. It lands you at the same spot as negative pi over 6, but very technically speaking, that's not the angle. The angle of negative 37 pi over 6 is going backwards, which is clockwise, once, twice, 3 times, and then another 30 degrees. So here's negative 37 pi over 6. Okay, and finally D, and then I'm done. Negative 7 pi over 4. Where is that? Okay. So quite often for these problems, you want to aim for a coterminal angle. Give me a nice angle that lands in the same spot. Well, I can add 2 pi or any multiples of 2 pi. So what I did was I took the negative 7 pi over 4 and I added 8 pi over 4. So where'd you get that from? That's 2 pi, right? That reduces to 2 pi, but I want to get a common denominator. Just like over here, I wanted a common denominator of 6. And that lands me at pi over 4, which I'm comfortable with. I say, oh yeah, pi over 4, that's 45 degrees. So this negative angle lands me in the same spot as 45 degrees. So I go in a negative angle, not quite one full backwards revolution, but I land at the same spot as a 45-degree angle, pi over 4. So here is the angle, negative 7 pi over 4. Okay. So there we are. All right, folks. So for the homework, yeah, I was scheduled to have 2 days for this stuff, right? Let me mark this off. So I've done about half of 4.2. I was going to do the rest tomorrow. So we are here. So tomorrow again, 4.2. So most likely on Thursday, I'll get going on 4.3. But time-wise, I think we're going to be fine as it stands. Okay, so next time I'll do some more of the problems at the end here. And there's some problems involving arc length. Page 198, this formula. And then area of a circular sector. Page 188, this formula. Okay, so hopefully I'll be able to show you that starting tomorrow. Okay. All right, but I've given you everything up to 23-ish. Yeah, so now you should be able to do everything up to here. And so tomorrow I'll start doing the rest of the problems, hopefully from this section. All right, so I'm done, folks. Let me stop the share and check the chat. If I get anything else here. Okay, anybody with a question, please? All right, that's all for today, folks. So have a good day, and we'll see you next time. Okay, all right, bye, everybody.